huh? Okay, 10, 18. So we said that was a normal distribution. Well, here's the interesting thing. Lots of traits in lots of species are distributed normally. This is pretty common, where the average value for any trait, for ear length, foot size, pinky length, fur color, if we did an arrangement of fur colors from darkest to lightest, very often what we see is a normal distribution. Sometimes gets called a bell curve, because if you have a good imagination, you can imagine that that's a little bell. I don't really see it, but whatever. And it means you've got a lot of people here in the middle. If you take probability and statistics with Mr. Andres, you'll hear the term standard deviation. In a normal distribution, the bulk of the population is within one standard deviation of average, of mean. When you get out to these tail ends, there aren't a whole lot of individuals there. If we think about this in terms of human height, are there people who are 24 inches tall? Yes, there are. Adult height, 24 inches. There are individuals. Are there a lot of them? No. Are there individuals who are over 7 feet tall? Yes, there are. There are not a lot of them. So you've got the bulk of individuals. You know, again, if we say this is human height, and we say this is human height for females, and I told you the other day, 5'5" is dead average for an American female. Do we have lots of women who are 5'6" and 5'4"? Yeah. Do we have lots of women who are 5'7" and 5'3"? Yeah. The farther out we get from that middle, the fewer individuals we expect to see. Do we have a lot of women who are 4 feet tall? Not a lot. There are women who are 4 feet tall. Do we have a lot of women who are 6'2"? Yeah, but not a lot. In a normal distribution, the bulk of your individuals are near that average. Have I emphasized that enough yet? Is there any other way I could say that? Probably not. Probably not. Okay. Now, are all traits distributed normally? No. No, as a matter of fact, they're not. Okay, well, evolution changes the distribution of those traits. So we have skewed distributions, we have bimodal distributions, we have normal distributions. The environment, let's make this clear. The environment can change the distribution of those traits. When that distribution changes over time, that is evolution. That's all it is. So let's imagine a scenario in which the environment changes the distribution. And let me tell you a story about a rabbit. Whoops. There's my rabbit. It's a terrible rabbit, but you know, it'll have to do. Now, rabbits, what's the big characteristic feature of rabbits other than their adorable fluffy tails?
Ears.
Ears! They got big old ears. Why do they have big old ears? Okay, 2 reasons, one of which was named the low-hanging fruit. They got big old ears because guess what wants to eat a rabbit? Everything! Rabbits are paranoid for a reason. Everything wants to eat rabbits. They are a prey species to the nth degree. There's nothing out there that wouldn't like some tasty, crunchy little bunny bits. Coyotes. What else? Humans. What else? Dogs. What else? Cats. What else? What? T-Rex. Yeah, not so much. What? No, not so much. Okay. Pretty much anything that we have in this ecosystem which preys on anything else would like to eat a rabbit. So it is distinctly to their advantage to be able to hear what's coming. They're jumpy for a reason. Now, why else do they have big ears? There's another reason. Did you know that? What? Ah, who here has seen the radiator in a car? What is the function of a radiator in a car? It's the part in the front where the coolant goes through. Cools the engine. There's liquid flowing through this thing and wind hits it up front And that wind hitting that liquid cools the liquid down, heat gets lost out into the atmosphere, and then that liquid circulates through the engine and it cools off the engine so the engine doesn't overheat and seize up. Ooh, that's convenient. Yeah. Guess what rabbits' ears are?
Radiator.
Big old fat radiator. I raised rabbits in 4-H, and certain breeds of rabbits have certain specifications for ear length. Did you know that? Anybody here do like show dogs, show cattle, show horses, show pigs, show sheep, show geese? No. Okay. Anybody here showed any kind of animal ever? Really? Aw, that's so sad. Oh, Gavin. Okay. So, in rabbit breeding, different breeds of rabbits have different breed specifications. Okay. This little one here, that would be a Netherland dwarf, and Netherland dwarves have teeny tiny little ears. And I think, as I remember, their ears can't be any more than like 3.5 inches long. It's ridiculously short. Teeny little ears. Then you have something like the French Lop. I'm doing a terrible French Lop here, but that's okay. I'll be forgiven, I'm sure. And French Lop ears, and I don't know the metric measurements, French Lops have to have ears that are 27 inches tip to tip. It's crazy. In the wild, these things would die immediately because they'd trip over their ears and then the coyote would get them. But they're show rabbits. Nobody cares. If you are breeding your rabbits, if you are a 4-H'er breeding rabbits, and you happen to have a litter of kits in the summer, here's an interesting thing about the environment and baby bunnies. So ear length and most sources of variation comes from two things. What are the two things from your variation lab? One of them is DNA, your genes. Yeah, DNA. One of them is your genes. So if you're raising, Netherland dwarfs and you have two short-eared parents, you're probably going to have pretty short-eared offspring. What's the other source of variation? Think. Oh, I turned my lab in, or I could just look at the front of my lab. What was it? What was the other source of variation? The environment. The environment. The other source of variation. You got your genes, you got your environment. So if you are, boy, that's a terrible piece of DNA. Let me get rid of that. So two sources of variation. Genes, and all genes are, you remember, are little tiny short pieces of DNA, and the environment. So when you're raising rabbits, if you have a litter of kits, baby rabbits are called kits, like kittens without the tins. Depending on how hot it is where those baby rabbits are, the temperature of their environment actually also helps determine their ear length. What did we say the ears did? They were a what system? Cooling system. Yeah, they're the radiators. Because those ears are really, really thin. You see, now I think I need to keep rabbits again so that I can bring rabbits in for this and let them hop around the classroom. And you could all pet the bunnies and look at their ears. Wouldn't that be nice?
Yes.
Maybe I should do that. My daughter would be thrilled. So anyway, those ears are really thin and they've got a lot of blood vessels in them. I should have a picture of rabbit ears. I don't. I'm sorry, I'm failing you. The blood flows through those very thin ears. What parts of your body get cold fastest when you're out on a cold day? Your hands, things that are thin and small and exposed, and the blood flows close to the surface. Well, the blood flow is close to the surface in those rabbits' ears. Your dog's ears are the same way. If you feel a dog's ears, there's a lot of blood vessels in there, and on a cold day, those ears will be really, really cold. Not to the same degree as rabbits, but they also function as a radiator. So if your baby bunnies are born when it's really, really hot, there's some flexibility in their genes. Do you think living in a really hot environment as baby bunnies would make their ears longer or shorter? Longer. So if you're raising these little guys and their ears can only be 3.5 inches long, and you have a litter of kits in August, what do? I'll tell you what you do. You put frozen 2-liter bottles full of water in their cage to keep it cool. You give them bunny air conditioning. You bring them into the house. You put fans on the hutches. Because you don't want those ears to get any longer. Now, what if you're raising these stupid things, French Lops, and you have a litter of kits born in January? What do you think is going to happen to their ears because of the environmental conditions? Their ears are not going to meet that 27 inches tip to tip, are they? So what are you going to do? You're going to put a heater in the hutch. You're going to drag the hutch into the garage. You're going to fire up the wood stove in the garage. You're going to do whatever you can. You're going to keep those babies warm. You're going to run electric heating pads out to the hutches and put them in there because you want to make sure that those ears are long enough. And if those baby rabbits are cold, though their genetics may be geared for pretty long ears, they're not going to be as long as they possibly could. Okay? So the environment can affect how a trait is expressed in an individual. Let's make a note of that, shall we? I hit recording again. Okay, environment can affect the way a trait is expressed, and we're going to turn from domestic rabbits to wild rabbits. So 2 years ago, in the burbs of Pennsylvania, and I'm an avid gardener. I mean, I used to have sort of small-scale farm production, and now I just have crazy gardens. And so being a crazy garden lady, I'm always on the lookout in my neighborhood for what is chewing holes in my kale, my chard, my carrot tops, what just took down my broccoli to stubs. And 2 years ago, I noticed a peculiar thing. I love domestic rabbits. Like I said, I raised them. Oh my gosh, I've bottle fed more baby bunnies than I can count. Little wild rabbits, I kind of hate them because they have decimated my spinach, my chard, my kale, my broccoli. They ate all my lettuce. They chewed off all my pepper plants one year. I was really ticked. Little wild rabbits, aren't they cute? And I happened to see a little wild rabbit with the stubbiest ears I had ever seen. Like, seriously, Netherland dwarf stubby. This was right after all my pepper plants got chewed off, and I thought to myself, ha ha, you're going to die. You're not going to hear the coyote. You're not going to hear the coyote. Against all odds, it survived. So little Mr. Stubby Ears, or Ms. Stubby Ears, I didn't get that close, lived. I kept seeing this rabbit all summer. All summer I kept seeing this rabbit, and I kept thinking, it's not going to make it. There's no way this rabbit's going to make it. It can't hear what's coming. Well, hold on. Let me set aside little Ms., we'll call her Ms. Stubby Ears for a moment. Because here's what I have not done in my neighborhood. In all my careful observations of the rabbit wildlife in my neighborhood, I have never gone out and sedated all the rabbits in my neighborhood. Would anybody like to volunteer for this little bit of research with me? Come to my neighborhood. We're going to sedate rabbits. We're going to, once they're unconscious, we're going to measure all their ears. We're going to carefully record the data on a graph. Maybe we'll put little tagging chips in them so we can track them, and those tagging chips will have their ear length on them, and we can see where the short-eared bunnies go and where the long-eared bunnies go. But I'm going to bet you something. I'm going to bet you that if we did this crazy little experiment, which I highly recommend any of you volunteer for, the graph of our rabbit ear length would look a little bit like, what do you think? I'm going to bet that it would look a little bit like a normal distribution, don't you think? What's so funny, gentlemen? Tagging rabbit ears? Nothing funny about it. This is deadly serious science. I'm going to bet you it would look like that. Now, on that distribution, where is Ms. Stubby Ears? She is way down here, isn't she? Little Miss Stubby Ears, she's on the short end of the graph. Now, are there rabbits in my neighborhood who are up here? Sure, I haven't seen them. But I'm sure they're there. And there are plenty of what I'll call completely prejudicially average, well, I'll say average-eared rabbits. We'll have a conversation about average and normal some other day. Little Miss Stubby Ears is way down there on the bottom end of this distribution of ear length in rabbits. Now, against all odds, Stubby survived. Serious. I see her. I saw her all summer long. Now, if Stubby was the only one of these little short ears, she looks really mad in that drawing. She never looked that angry when I saw her. She looked terrified, like most rabbits do all the time. She survived. And she apparently was successful. Now, how do I know that? Because next year, guess what I saw?
Stubby.
Oh, I didn't see one Stubby.
Stubby Juniors.
I saw lots of Stubby Juniors. I saw tons of Stubby Juniors. One Stubby Junior, one Stubby Junior, two, because you know what they say about rabbits? They breed like rabbits. So next year, there were lots of little Stubby Juniors. Actually, I did not count them and I did not tag them, so I can't account for replication. So I don't know how many Stubby Juniors there were. But what I know is that the next year, in my neighborhood, I saw a whole lot of short-eared rabbits. Stubby did well. Stubby did very well. Stubby was successful. Stubby not only survived, but Stubby survived to pass on her genes. What in the environment could reward Stubby? What could make... Now, let's talk a little bit about energy expenditure and making things worth your while. Does it take energy to grow a body? Yes. Does it take energy to get taller? Yes. Does it take energy to grow bigger ears? Yes. The longer your ears are, the more calories you have to consume to support those ears every single day. Is there an advantage to having shorter ears? Yeah. Just like somebody who is 6 feet tall and somebody who is 5 feet tall. The 6-footer needs more calories every single day than the 5-footer to sustain the amount of body that they have. Stubby needs fewer calories, by chewing off my pepper plants, thank you very much, than a similar rabbit with long ears. There's an advantage for Stubby to having short ears. Now, what if we had a couple of cool summers? Is there any advantage to Stubby to having short ears if we have a cool summer?
Small ears.
Small ears. She's not losing what? She's not losing heat through those ears. She doesn't have big, gigantic ears that she's losing a lot of heat through. That's also an energy savings for poor little Stubby. Well, I should not say poor little Stubby. She did very well for herself. Now, is there any disadvantage to a rabbit to having short ears? She may not hear everything that would like to eat her. Her offspring may not hear everything that would like to eat her. She loses a little bit of edge in terms of being aware of predators. So, if, as I'm suggesting here, the following year, the distribution in my neighborhood had changed what was responsible for that change. So we went from, I'm assuming, and like I said, I did not sedate, measure, count, tag every rabbit in my neighborhood, but I'm guessing that the distribution skewed towards the bottom. What affected that change? Stubby. Stubby and her darn successful reproduction. But obviously the environment worked out for her. The environment can work for you or it can work against you. Now, what if somebody in a fit of utter mischief had brought 3 packs of ravenous coyotes, and of course coyotes don't really travel in packs, they travel in small family groups, usually 2 to 5, usually a mated pair and their offspring. It's not really a pack like we think of with wolves. What if somebody had released a whole bunch of coyotes into my suburban neighborhood? Oh, I don't think we'd be seeing Stubby and Stubby Jr. and Stubby Jr. 2 and Stubby Jr. 3 and Stubby Jr. 4. Because Stubby can't hear! Well, she can hear. But, yeah, she heard that. But Stubby isn't as able to hear sounds necessarily as soon as a rabbit with longer ears. The environment pushes how distributions change. The environment can be awesome for a particular variation, or the environment can be terrible for a particular variation. The environment drives these changes. If over 20 generations, the environment is awesome for Stubby and all of her generations of Stubby Juniors, then evolution will have occurred and my neighborhood will be home to possibly a new species of short-eared rabbit. They look really funny, but there are a bunch of them in my neighborhood now. And I do say hi, Stubby, when I see them. The environment pushes how distributions change. The environment either rewards or sort of punishes via death. Death by coyote, death by freezing to death, death by overheating. The environment either rewards or punishes variations. It's funny how that works. So what I'm going to have you do now, there is a recall quiz that has just posted minutes ago to Classroom. I would like you to ask any questions that you have. Any questions? Any thoughts? 9? Okay, then you can put your notes away. It's not a with notes recall quiz, so fold up the notes, flip them over, and I'd like you to take the recall quiz.